Welcome to Brain Vision.
This problem they give us of how g varies with the latitude of your location on Earth. And so that's this value phi here is the latitude in radians. And so g is given by this formula is in the problem. It's 32.09 times 1 plus 0.0053 sine squared of phi. So, and that takes into account the effect of the rotation of the Earth, as well as the fact that it's not truly spherical. Knowing that the weight of a silver bar has been officially designated as 5 pounds, determined to 4 significant digits the mass in slugs and the weight in pounds at a few different latitudes. So we're going to basically find this average G and assume that it's designated as 5 pounds, meaning that's an average. Again, I'm not sure how they necessarily has officially been designated as 5 pounds, but somehow we need to get the mass, and I just took the average gravitational constant, and that means that we can let's see here, we just take, and I took the average over we can average over from 0 to pi over 2. Okay, so that's kind of like this average, and obviously it's symmetric, so it doesn't, we can just take half the range. So I averaged that, so we integrate g from 0 to pi over 2, and then divide by the integral from 0 to pi over 2, or just pi over 2, to get the average value for g. And doing that, we get this integral here. We integrate this, and we get this, and we need to evaluate it between these range. And in the end, we get 32.175 feet per second squared. So, roughly 32.2, like we thought, that we normally use. Now, the mass then is the weight, which is 5 pounds, divided by g, and that turns out to be 1.554 slugs. So now we can find the weight at different locations. So we know the mass now. So the weight is the mass times gravity, and now gravity is a function of phi. So we have the weight as a function of phi here. And we can, this thing, we can multiply this through, and then we can set phi equals 0. Because that's the first value they asked for, the latitude of 0. And that means we have, let's see here, this is 0, so I think, wait a minute, latitudes start at the top, so we're actually moving down, so basically we just took this range, right? So this would be at the North Pole. And so we plug, this is 0, so we just get, this times this, and that winds up being 4.987 pounds. So at the North Pole, with the latitude of 0, is that right? I think it must be right, because that's where this is a minimum, and I think the gravity is a minimum at the poles, which makes sense. Anyway, I think so. So anyway, at that point, when phi equals 0, we have, it weighs slightly less. And at 45 degrees, we see that it weighs almost exactly 5 pounds. So, at 45 degrees, we're here, and that's basically probably, North America, Europe kind of latitudes. And then we at 60 degrees, I guess this would be theoretically closer to the equator. No, I think this is 0 is the equator, because if we're spinning around this axis, let's see here, things should weigh less because of the centrifugal acceleration wanting to pull things away from the axis. But I think the Earth is slightly oblong around that axis, so G from G itself, the gravitational force would be greater. So actually, I'm not sure, where if this is I think my guess, initial thought was phi was at the phi was 0 at the North Pole or at the equator. So let me see. Let's look this up. Latitude. The latitude is, yeah, it's 0 at the equator. Yeah. It's 0 at the equator. Alright, so I was right initially. So at the equator is when it's actually G is less because of the rotation speed of the Earth. So at the equator here, we're at slightly less weight. At, roughly, well, 45 is kind of, roughly, again, North America, Europe. And so that's where we actually get 5 pounds. And that's usually why we wind up using, 32.2, because most people, and actually most of our, I guess, I'm not sure if where China is in that, China's up there too. So, most of our population is in the northern hemisphere. So, around 30 to 60 degrees. And so then if we go up to 60 degrees, well, yeah, 30 to 45 degrees. So if we go up to 60 degrees, that's kind of Alaska range-ish. And so then it weighs a little bit more, a slightly greater weight up at 60 degrees. And then if we went to 90, then we'd have, slightly higher value for the weight.